people. It has been a minute. Sorry, I've been dealing with a couple of things, although I'm grateful to those of you who reached out and said, hey man, you were in the middle of something, and then you vanished. Work got on top of me a little bit, along with life in general, but here I am back again, eager to continue, and hopefully we will pick up some momentum and rock out the back half of this set of tutorials. So without further ado, before we get into the real nitty-gritty of some of the practical stuff, which I know we've all been waiting for, the last thing we have to discuss is the HDFX and understanding some of the things that are unique and interesting to the S650 ECU. So without further ado, let's jump into it. Tonight, as I do this late on a Friday, we are looking at what is the HDFX. 11 herbs and spices, the secret to blending success. We're going to look at the magic of load, the torque monster, how to face it, VCT and going the distance, the fueling forecast, and then at the end, putting it all together, the HDFX modes. Now listen, if you are someone who does not want to look at anything like math, if the idea of something called predictive modeling analytics bothers you, you may want to go to the end of this video and just look at the HDFX modes, because it all builds up to those, right? And those are some modes that you need to know about, because when we begin logging, we're going to want to make sure every time we look at the log, probably the first thing we want to see is, was there knock retard? The second thing we're going to want to see is which HDFX mode we are in, because that gives a lot of context and clues to what it is we want to be doing with the engine, right? So you may want to jump, but if you are the kind of person like me who's just fascinated by all things tuning and has been looking for answers and they've been coming up short, then by all means, buckle in. What is the HDFX? The HDFX, or High Degree of Freedom Execution Model, is the collective suite of predictive Okay, it is the machine learning model, right? I trust you can read that on your own. It is the name of the Ford module. Think of it as like the AI, although it's not a real AI, but I'm not going to even touch that. What I mean by that, that's a whole other set of videos. But it's the product that sits in between you, the driver, and the raw operation of the engine. You have a ride-along phantom in the car that has a heavy, invisible hand in everything that the engine is doing. And you, as the tuner, need to understand what the HDFX is and how to make friends with it, because if you don't, it will get in the way of what it is you are trying to do. And so remember, we just talked about something called the torque monster. That's going to be something really important, right? But just the basics of this is something that you really do need to understand if you're going to take full advantage of everything that ECU has to offer. It's essentially the computer. It's not just the ECU, it is the combined sort of machine learning that Ford gave us that is controlling the engine. What it does, so it's a decision-making apparatus. It's monitoring hundreds of those sensors in real time. We talked previously about logging. Like we perform logging, right? The HDFX is in a state of continuous logging, looking at all those sensors in real time, and it's performing thousands of these calculations to perform the to understand and command the optimum ASF model, right? Which I'm the air, spark, and fueling model. Right, so at any given moment, what's coming in, what's getting crunched, and what's going out, it's monitoring all of that. What is one of the biggest differences between the S650 and the S550? So S550, there were two versions of it, I think, right? There's 551 and 552. I think 550 Part 2 came, 2017 to 23. The S650 is a generational leap, others have said, not really that different from the 550. In fact, when you really look at it, it's like, okay, we have some, different headlights, slightly different body style in some spots. I know quarter panels, for example, are not interchangeable between the two. But if I was to draw a circle around the biggest thing, what's the biggest change? It would probably be this HDFX and the computer in general. This is a generational leap beyond other Coyotes. I've touched a lot of ECUs in my lifetime. The ECU in this S650 is one of the fastest computers I've ever seen that's been in a car. And when you think about how these systems have to be monitored and approved by the NTSB, the Traffic Safety Board, the speed we have on this thing is pretty remarkable for something that needs to, live up to a lot of quality standards. The way they've designed this, I suspect that it is solid state. In fact, I'm 99.9% sure it's a solid state device, so the same quickness you get out of, like, if you've got a PS5 and you noticed it was a generational difference between, games used to take forever to load and now they just spin right up, that's all solid state magic, man. And the S650 really takes advantage of really a lot of the computing that has followed the Bitcoin mining era, right? It is really efficient, really fast, and really quick. And that changes a number of things about what we can do, right? All for the better in terms of the power given to us as tuners, but the cost is you've got to have the knowledge, right? So yes, that is what it is. So what does it do? Why is it so interesting? So the X in HDFX refers to execution, right, or the executive decision-making command. It has total authority over the ECU and its commanded parameters. So it's the captain, right? It's the buck stops with the HDFX. It's monitoring all things, the state of the car, what the car wants to do, also you as the driver, what it is you're trying to do. It takes a look at all that, and it makes the decision. And it has the high degree of freedom is, I get to decide as the HDFX whether or not I'm going to let you have the power you asked for, right? Whether or not maybe I need to put the car in limp mode because something's going on, right? The HDFX is a genie that saves you from yourself as a tuner and as a driver, right? It's first and foremost concerned with the safety and proper operation of the vehicle, making sure the engine doesn't grenade itself. It has a number of ways to push you back into safety if you keep trying to jump over a cliff, right? That's the whole point, right? Is safety first, and then from there, efficient operation. And then once you have, I saw F1 recently, and what did they have a phrase? Slow is smooth, and smooth is fast, right? The HDFX spans that thinking, right? It keeps things smooth and running right, and where you have that, you have power and speed, right? So, how does it work? This thing is loaded with hundreds of tables, parameters, various lookups, all the different charts. If you've done any tuning before, you know there are a number of maps or tables that have all the different command parameters, and they're broken out by things like, in speed density tuning, right? We have our pressure down one side, we have our RPM down the other side, and in the middle is the ideal state of volumetric efficiency. And where I know, we'll see this later, where I know volumetric efficiency, I know the fuel that I need to have, right? So that, and amongst other things, it's constantly looking up things that are stored in static tables. They don't change, right? But the sensors are constantly changing. And so it can read the sensors, look at the lookups, decide with what it is I want to do, and then from there perform all the calculations that need to happen to get me where I want to be. And the Ford engineers, they've done this for generations, so they're leveraging all the knowledge they have from the previous gens, and then on the current S650 and the Gen 4 Coyotes, thousands of hours of bench testing went into really perfectly calibrating these tables and the way this thing does the number crunching. Like I said, hundreds of times a second, it's looking at these tables, comparing it to the data, and it's performing a lot of, there's this magic word, blending. And blending is where you have interstitial lookup values that are interpolated, which is by fancy way of saying when you're between two things, if you're between two tables, or if you've got a load that is sort of in between two rows in a table, it says, well, take half from each, right? And do the math for each of those and then scale it by 50%. It can do all of that blending in real time, so we don't have to. Very amazing technology, frankly, in cars. This is a model, so this is just a cute little graphic. If you didn't like the previous slide, or if you're befuddled, right, this is all it does. The HDFX. It has the sensor inputs, it does lookups, performs calculations, and then from there commands parameters. So air, fuel, spark, right? That's what it does. The magic of load. What's so magic about it? Why do I worry about it? Because load is defined as a function of the open throttle position, which is then a function of the total air pressure in the manifold. So remember that engines, as they're operating, are in a state of constant vacuum, especially in naturally aspirated, right? It's always got less pressure inside it than the outside, and so when I tip open that throttle plate, air begins rushing in. And when that happens, all hell breaks loose, right? Because the whole point of wide open throttle is you open that throttle plate open, right? And the pressure goes up, massively inside the crankcase. When that happens, that is a fundamental state of the engine. And one of the very first things the HDFX looks at is what is the load right now and where does the load need to go, right? And it's all about airflow. It is like the primary driver of pretty much every decision the HDFX is going to make. When we are in a low RPM, low load state, that's when we're just cruising on the interstate, right? Or we're just cruising around town. That is a very well accounted for and engineered state. It's engineered for incredible efficiency in those situations. When we're in a high RPM, high load state, that's where we're usually at a wide open throttle. That's where we're very excited and doing some spirited driving, right? It's party time, fun time. And then sometimes we're in low RPM but high load states where I've been cruising along and suddenly I want to increase my speed, like really quickly, right? I want to accelerate quite a bit. And then what happens is a state is presented where we're at low RPM, say 2300 RPM, and we drop a gear and we want to go right up to 4, 5, 6,000 RPM, right? And the first thing that happens to begin getting us there is the throttle plate opens and the load of the engine goes up dramatically. The HDFX apparatus, right, is monitoring load, and when those things happen, all sorts of things start to happen in terms of the calculations and decision making. A little sidebar here. Remember, if the ECU knows the volumetric efficiency, if it knows what the load is, it automatically knows what fuel is too. Fuel comes along for the ride because of the lookups and calculations. Previously, we've talked about how that happens, right? But this, or that it does happen. This is the real guts of it, right? The HDFX is the thing in the middle that it sees load spike, and it automatically is like, gotta have more fuel, right? And how I get from low fueling to high fueling, tipping in and all that, that's what I can figure out now that I've sensed this. So load, very primary. The torque monster. So this is another feature of the HDFX. Remember I said it's something that will keep us safe. So if load is one of the things that's driving this, right? Torque demand is another. Load, think of bottom up, right? I'm at the bottom and I'm trying to go up in terms of load. Torque monster's top down. Right, so based on the load and accelerator position, the driver demand torque is registered by the system, right? So you stomp on the pedal, load goes up, the HDFX notices and says, okay, the driver is demanding torque. Doesn't mean I'm going to give it to him, right? It means I'm going to start making decisions. I'm going to look at what the load was. I'm going to look at models of where it should go from here. I'm going to look at parameters for my air, my spark, and my fueling. I'm going to check a number of things. Right, and then I know as the HDFX all the different possible engine states in my table lookups, and I know for any of these what the torque threshold is, right? So the engineer's ceiling of what power is safe to deliver at any given moment. Torque monster is a situation, and it's the bane of the tuner, right, is when you are increasing your airflow or other power adders, right? You've got a boost to pump, giving you more fuel. You've got bigger injectors. You're really getting ready to go to town, maybe with some forced induction, and we start really, not even that. You don't even need that. Just like, let's say I have long tube headers on, right, and I'm tuning. The long tube headers, they can add with tuning up to like 70 horsepower, but you'll put them on and you'll calibrate your MAF and your speed density, and then start stomping on the pedal, and the power's not there. And you look in the logs, because you're logging, right? And you start to notice situations where we'll show you later on, right? Here's an indication here where the torque calculation from the HDFX said, no, I don't think that's a safe amount of power. I'm going to limit the torque, right? And so that's where as tuners, we have to go in and say, okay, we're going to increase those ceilings, right? Because the software itself is what's getting in the way, right? This is why we need to know about how the HDFX works, right? So that's one thing to think about. So we got load was getting monitored. Driver demand for torque is getting monitored. Other things we're checking out and monitoring is the HDFX. Variable cam timing. So remember that the S650 comes with 4 twin independent camshafts, right? So over each bank of 4 cylinders, there is an exhaust and an intake set of camshafts, right? So 2 on bank 1 and 2 on bank 2, so 4 total, right? Those cams are one of the big tools that the HDFX has to manipulate a number of different settings, airflow, there's the intake manifold runner control, or all kinds of little things that it can do and move using the phasers. Remember we talked about that, to move through 26 mapped points. And those 26 map points account for the broad spectrum of engine states. Let's go ahead and if I come over to my software here, again, this is the tune I'm currently running, and you can see here under our airflow and our speed density, we have all of these different map points that we're accounting for. And if you come to the variable camshaft tables, and this is a sneak preview of what's coming at the end, you'll see that those map points are accounted for here in terms of the different VCT modes that are called, right? Fundamental stuff, right? Knowing how these 26 tables work and how we move through them. So again, remember blending. The HDFX looks at these 26 states and it moves through them from one to the other, blending them. There's various possibilities for the current state of the engine, the power demand, and all of these different predictive machine learning models it has for power and efficiency. Key thing here is, in addition to the mapped points, there are distance tables. And the whole purpose, I didn't understand these at first. It took me a while to wrap my head around this, and the skies parted and it became a sunny day when I realized the whole purpose of the distance tables is from any mapped point commanded by a VCT schedule. We're going to look at those in a sec. For anywhere in the engine I am, right? The distance tables will tell me how far I am from optimal power, or really which mapped point I would need to go to for optimal power. This is a big deal because the HDFX always knows how to scale down power, but in terms of efficient operation and moving towards power quickly, right? Because race car, these distance tables will tell it at any given moment. If you're here and you want to really ramp up power, then you need to go here, right? And those distances, they create a defined path. And so that path is further defined in the snap to point and snap to line tables, right? And if you really get deep into this, you can actually graph on a grid the different states in map points. And you can see in real time how the HDFX moves through these circular cyclical patterns, right, as it moves through the different states. I'm not going to get into that here. It's beyond the scope of this tutorial. But these are the key components of the HDFX and how it's moving through all these states of information and flow, right, operation. Okay, the fueling forecast. So These are some things that you want to watch out for as you're tuning, because the HDFX has a lot of arrows in the quiver for things it can do to modify how the engine is operating. And these are little things where, as we start to get into certainly math and speed density tuning in the next couple of sessions here, it's important to know that these are some of the little tricks, these little goblins that can leap out at you, because they're the HDFX doing things that are, the icing on a cake, right? That makes it super awesome and efficient, where we're still worried about baking the basic sponge, right? So just highlighting these now so we understand later on, like things we're gonna have to worry about. So one thing is math adaptation. This is something where the mass airflow sensors have a predictive modeling package that, as different sets of airflow conditions are happening in the engine, right, it can sense from, if this is where I am and this is where I want to go, this is exactly how I would change it, right? I could talk more about this, but I'm not going to because Coyote generations 1 through 3 had math adaptation. On the S650, by default, it is disabled. And that is a curious thing. Why would you disable this? There's 2 reasons, in my view. Probably the most important one is that the fuel trims are governed by speed density on the S650. I cannot say that enough, because that's a departure from previous gens. And it's joining its cousin, the F150, of why it is they did that, right? Among other reasons. Speed density is very accurate. It's if you are a little bit snobbish about your accuracy, speed density probably beats out math. But the other thing is, with the fact that the S650 constantly operates in closed loop, even at wide open throttle, being able to use the LTFT and STFT trims essentially in real time, math adaptation and the math that's being performed there, because the ECU is so quick and powerful and calculates so quickly, probably this was redundant, and at some point the engineer said, you know what, we're just going to disable it. Possibly because it was interfering with other logic models, right? So yes, it is gone. Okay. LTFT and STFT. So we talked about these and logging and how they're used and how it is eventually used to compute the error and fueling rep. You can see the previous slide set on that. The thing that's interesting about this is, again, getting to the fact that the S650 ECU is so darn quick. The predictive modeling of the LTFT is, from one cycle to the next, shorter. In that the LTFTs flicker is a good word for it, more than they did in previous generations. They're quicker, right? Short term, still short term, right? Lightning fast, but long term, because it's a little quicker, you can do blended averages and you can do calibration, especially because we're in open loop, or closed loop rather, so much. You can look at LTFT and STFT combined in some cases. Now, it's not necessarily the best practice, right? But it's a good hack, and you can get away with it because the ECU is so quick. That's all I'm going to say for now, right? Because later on, when we look at math calibration and speed density, that'll be more something we'll talk about. And we'll probably do it both ways, because we're good tuners and we like to make sure that we're doing shit right. Okay, so another key thing here, and Chevy has this too, but there is a predictive modeler for volumetric efficiency that is mapping and accounting for, from state to state, the airflow within cylinders, right? And that Silair anticipation, if I come over here, if you go to airflow, and if you go to general here, right, here's the math curves that we're going to calibrate. Down here, Silair anticipation, and HP Tuners even gives you a cool little, sense of what this is. When enabled, the Silair filters enabled a complex prediction algorithm to calculate cylinder air mass. Essentially, it's a speed density computer, right? And it's looking at the different states of the engine, and making calls about, right? Especially for transient states when we're either tipping in and out of power or we're at partial throttle. If we're moving from one state to the next, the Cylaire anticipation is the bread and butter predictive modeler. Now, previous generations have had it. Other big blocks have it, right? The S650 does have it. And if we're going to tune our MAF and speed density, we have to worry about cylinder anticipation because we don't want the computer making some of those corrective calls if we're calibrating our core tables. The whole point is to get closer to truth without the computer helping us, right? So this is something we have to worry about. And so later on, you'll see when we get starting to tuning, we turn this off, right? So that's one thing that can get in the way. One of the other things is the deceleration tracking, right? So if you are pushing a lot of fuel in a rich state through the engine because you've been commanding power, and then you suddenly let off the throttle, you've got a lot of fuel as that door closes, right? There's still some extra fuel left over, and it's a mist, right? And that mist moves through, it doesn't get combusted, and it hits the hot exhaust, and guess what? It's a vapor. It's hot, right? Pop, 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 pop. It combusts. And you will even hear sometimes as you're moving through the gears, you'll come to a stop, move from second to third. My wife loves this, right? You'll hear a little pop in the back. She's like, amazing, the car farts. I'm like, yes, it does. And if you are of the ilk that you want a burble tune, taking advantage of this process is what the burble tune is all about. You're deliberately commanding richer fuel in a lot of different situations to continuously hit that pipe and pop, pop, burble, burble, right? Just be aware you're deliberately running your engine inefficiently for lulls. And hey, it's your car. Do whatever you want. But it is one of those modelers that we have to worry about and possibly disable if we're going to get to true fueling calibration, right? Because these are all things the HDFX is doing to change fueling on you that you may not be aware of. Okay, other things. Yes, so catalytic converter protection. There are things in the HDFX that are constantly monitoring the exhaust gases, and if things are getting too hot, so I think 1700 Fahrenheit, once you get beyond those points, maybe it's 1900, things get dicey, and you do not want to melt your catalytic converters because they are an arm and a leg. I think we're talking 1500, 2000 maybe, to get another one. If you look at long tube headers without cats, you're talking, what, 1,000, 1,500, right? But when you start adding those cats in, especially high output cats, green catalytic converters that can take that kind of heat, wow, those are now $3,400. $3,800, right? For a nice set of Cook's high output green catalytic converters on your long tube headers, right? Because the cats can melt very easily, and when your cats melt, man, bad things, codes get thrown. Your mechanic starts looking at you like, what the hell did you do to this thing, right? So just the HDFX, to preserve the catalytic converters, will sometimes, stop the current, whatever it is you're doing, right? Oh, you're demanding power? No, you're not. No, because I don't want you to melt your cat. Okay. What was the point of all this? Here's the point. These are the different HDFX modes that in our logs we will be able to see at any given moment what mapped point we are in. And guess what? It'll usually be a blend of several map points, and we will see the VCT mode that we're in, and it will be one of the following. It may be optimal stability, right? And this is the smoothest, most stable engine operation. It is when you are driving down the road and you are at low engine loads, it keeps this running it's just optimal, right? So when you are at idle, right, this is definitely something that is controlling the different parameters of the engine. Okay, often you'll see that idle, we're in optimal stability. Emissions reduction. we really don't have to worry about this one. This is where, when you first do a cold start, emissions reduction will warm up the catalytic converter as quickly as possible to get it working, and it really puts power into that and prevents things from getting too crazy in terms of fueling and air until that cat is warmed up. It really only lasts about 30 seconds. It's not something, because when we are logging, we wait until we're at operating temperature before we do our logging. We don't have to worry about this, so I won't say any more about it. Fuel economy. Okay, so combustion stability. When you start looking at the four-stroke cycle or the auto cycle, you learn that there are two modes, right? One is power, lots of it, and how you do your timing and how you adjust your cam intake and exhaust angles, right? We do one set of things, right? If we're just going for economy, though, we use the camshafts in a very different way that is referred to as the Atkinson cycle, and that has things happening at it's almost like it's offbeat. Where in terms of when it puts the fuel in, and basically you get about the same amount of power you would get with a third less fuel when you're running in an Atkinson cycle. The downside, of course, is that if you suddenly want power, you need to depart from the Atkinson cycle and move to a more power-based. But that FE mode, right, is when we are preserving fuel to the greatest extent possible. And then we have our best drivability. This is also a blend of fuel economy, but it accounts for transient states and when we're trying to load. So again, if we want to leave the Atkinson cycle, we can leave it and move away from it. But if we're still economic, if we're still efficient, we're in our best drivability mode, right? Or the fuel economy drive. There's two more here. Okay. Optimum power. This is the fun one, okay? When you are at wide open throttle, the HDFX looks at the distance tables and says, okay, here we go. Moves to the map point that is quicker to get to a point where you've got maximum breathing, maximum fueling, maximum power, right? Tipping in to get there is something that the HDFX manages for you, so it seems smooth, both going into wide open throttle and coming off wide open throttle. It's the bread and butter, right? It's the reason we do all of this, is that mode. And then there's also a transient mode, and transient is when you will see it in the logs very intermittently, and it's when you're moving from low throttle, partial throttle, full throttle, and that's where it says, okay, look, if we're making changes and it's not quite sure where we're going, use this state to best manage the vehicle. Spoilers, that's where it's usually referring to either mapped point 0 if the intake manifold runner control is active, or is in a low state, so it's closed, right? Or at 10 if it's open and we're in higher load states, right? So it's map point 0 for low load, map point 10 for high load. And the reason I say that is you will see later on, mapped points 0 and 10 are far and away the most stable and generically all around performing of the different tables. 8 and 9 and 18 and 19 are very quick, very powerful. And then you will see in map points 20 through 25 are the optimum power points. It used to be there was really only one optimal power table, I think, on the Gen 3 Coyote. Again, a big change for the S650. We have 5 optimal power mapped points, 20 through 25. 26 is not used. So that is what we have. Shame on me, I do not have a slide for you. You can see my desktop instead of what it is we're going to be doing next time. But let me refer to maybe a previous one. Hang on one sec. Okay, so we looked at the HDF. So we've looked at the HDFX, right? Now we've gone through the theory stuff. Okay, so the next probably 6-7 workshops here are going to be praxis heavy. We're going to be spending a lot more time in HP tuners, looking at logs, showing how we, really get to the heart of calibrating. So next time I'll introduce the basic workflow that we're going to go through, and we're going to start looking at massed airflow tuning, right? So that calibration I like to do first, and then after that, we're going to get into, we've covered this, VCT schedule met points. We're not going to do that. We're not going to do that either. We can begin getting into the high-low method and the intake manifold runner controls. But yeah, this is where we start to get into the good stuff. To do the logging, calibration, getting ready for optimal power. And then in there, yep, we were going to do the speed density tutorials, right? So, but yeah, speed density, preparing for power, and then that'll be it. So, all right. Thanks a lot for tuning in, and go forth and happy tuning.